All right, guys. So we finished with linear models. This whole chapter is on different graphs, different models for different situations. So linear was that first one, line of best fit, and all that stuff. And now we'll be looking at quadratic models. Now, if that gives you nightmares from grade 10 and 11 math, don't worry. It's just one section, and we're just kind of doing the basics of it, guys. So for quadratic models, for example, the equation y equals negative x squared plus 2x plus 3 represents a quadratic equation. It can be represented in the table of values like shown below. Let's calculate the first and second differences, and that would be in the y value. Now, first I got to take my calculator and plug this in for and figure out my y values. All right, let me just make sure my pen's going to work for me today. Looks good. And so I got to go negative, and then negative 2 squared plus 2 times negative 2 plus 3. And that gives me a negative 5 for my first value. Next one's going to be negative 1, so I go negative bracket, negative 1. Close up my bracket, that's got to be squared plus 2 times negative 1 plus 3. Next value is 0. When I put all zeros in, I'm going to end up with 3 since the x squared and the 2x will both be 0. Now I got to put a 1 in, negative 1 squared plus 2 times 1 plus 3 gives me 4. I'm just going to double check that one because it takes a weird sort of jump there. So negative, then 1 squared plus 2 plus 3. No, it gives me 4 again. When I sub in a 2, my 2 squared plus 2 times 2 plus 3 gives me 3. Back down to 3. And then finally, the last one, it's going to be negative 3 squared plus 2 times 3 plus 3. And that gives me 0, so it's heading back down. So if we do the first difference, negative 5 to 0 is a 5 difference, 0 to 3 is a 3 difference, and then it's a 1 difference. Then it's a negative 1 difference to go from 4 down to 3, and then a negative 3 difference to go from 3 down to 0. So I'm just looking at how did you go from negative 5 to 0, plus 5. 0 to 3 is plus 3. 3 to 4 is plus 1. 4 to 3 is negative 1, and 3 to 0 is negative 3. The second difference, how do you go from 5 to 3? It's minus 2. 3 to 1, minus 2. 1 to negative 1, minus 2. 1 to negative 3, also minus 2. So we've calculated the first and the second differences in this one. Now, one of the things we're going to get in the summary note here is that when the second differences are equal, that is one thing that does tell you that it's a quadratic model. In any event, let's plot these points. So when x is negative 2, y is negative 5. So that's going to be right here. When x is negative 1, y is 0. When x is 0, y is 3. When x is 1, y is 4. When x is 2, y is back down to 3. And when y is 3, we're back down to 0. And you can see the symmetry in this. Instead of a line of best fit, in these cases, a curve of best fit is your better modeling system. And I could continue it from there if we needed to. But that's good enough. That's what the graphs are going to look like. They often will curve up, curve down like the one that we have here, and so on. In a quadratic relationship, the shape of the graph is called anybody? Yes, good. It is a parabola. The second differences are always the same. And the largest exponent in the equation is always a 2. Let me just go back and show you like that. Seeing this 2 here told us also that this is going to be a quadratic equation, and it should look like this or like this somewhere on that plot. All right, so we've got all of those things going for us there. The second differences were all the same. That exponent was there, and also when we graphed it, it was a parabola. So all of those things indicate for sure that this is a quadratic relationship. Some of the key features of a quadratic relationship would be their line of symmetry, their zeros or roots, and that is where they cross the x-axis. I'll put that in brackets. The vertex is that point right there where it, it's either its peak or it's the bottom of the valley or the highest peak. And then one last thing, again, we have a y-intercept in this thing. Does this parabola have a maximum or a minimum? Well, in this case, it has a minimum value because of the way that it opens up. You know, this one that opens like that will have a maximum, and the minimum, and one like this one is a minimum. That's pretty much the features that you're looking at. Again, this is just a quick review of quadratic relationships. And then your work for the rest of the week is just on page 303, 1 to 7, 10, and 17. Not a whole lot there, and several days to do it. I hope you can get it done. You don't have to think about math over the weekend. This will be your last work post for the week. After this, I'll probably just post a reminder on Friday to make sure you hand in the 2 assignments from this week, and also to fill in the attendance form. Again, I have to forward names of people who aren't connecting with that to the office. But that is pretty much it for now, folks. If you have any questions, continue to email me. If my videos aren't working, one person said one wasn't working. I hope that they figured it out. But good luck, guys. I'll right after I post this, I'll take some pictures from the section in the textbook so that those of you without access to a textbook from home can look at the questions there. Okay. Sometime I'm sure eventually I'm going to forget to do that, so please email me to tell me that I've forgotten to do that if that happens. Okay. Good luck. Bye for now.